How's it going? How's it going? Hello, hello. Here, let's swap back to the big scene. Um, Here we go. We can go to the weekly, and we can grab some papers. I wanted to talk about the schedule a little bit, but I'll wait till there's a couple people here. For now, let's just grab some papers. Hey, how's it going, Sams? Hello, hello. Last time I pre-opened papers, but then, um, I don't know. I felt like it really messed with the flow a little bit. I'm still gonna try not to spend too much time opening papers. I'm gonna try to pull the trigger quicker. We always open the highest upvoted one. World model evaluation sounds like something I should be interested in. Audiovisual generative. Um, I guess more video model stuff. This time with RL, which is neat. Multi-hop data synthesis. I've been interested in multi-hop reasoning in these video question answering things in general. I'm surprised. Are we not seeing? Am I skipping them because I just don't like them, or this is really vision centric now? Like I skipped a vision paper. I mean, we're not. It's not like I'm intentionally skipping language papers. Maybe Hugging Face just skews that way. Oh, thanks, Demir, for the compliment about the haircut. I actually do it myself. So I don't know. You know, actually, if you have a recommendation on clippers, let me know, because I've been using the same like. I bought the cheapest clippers I could 8 years ago. And like on the one hand, maybe it's crazy for me to cut my hair anyway, and I should just like pay someone to cut my hair. But on the other hand, if I'm gonna cut my hair, I should at least use decent clippers. And like my problem with these is that sometimes like look, this is kind of an issue with clippers in general, but like especially when I'm doing the back, if I'm going like not perfectly with the grain, it just doesn't cut. And then I don't know, I feel like more expensive clippers exist, and so there's gotta be like if I pay a little more, I get something a little better. I don't know. So let me know if anyone in the comments happens to have hair clipper recommendations. I'm all ears. I own the. Here, I can show you the one that I own. Um, let's see. Just so you know what I'm talking about, there are a few options. Like, I'm actually even looking, even Wall has a few different options. But I own the equivalent of this guy, I think. No, no, no. This looks more expensive than the one I own. I swear the one I got was like 20 bucks. But I'm not seeing a $20 one right now. Mine doesn't have, or does it? Mine doesn't have this many attachments. This is 9 minus 8, so I don't know. Um, Old. So if anyone actually has a recommendation, like I said, all ears. Anyway, let's try to grab a language paper in here. We're opening like a lot of vision ones. I'm gonna try not to. Sometimes my eyes are bigger than my stomach, I think, when it comes to opening these, even with the whole paper speedrun idea. And if you're new to the stream, or haven't seen any of the shorts or the long form or anything, this first part I like to read papers quickly or like skim them basically to see if we want to look at them closer, and then later we'll look at some closer that we actually like. And the strength of that is like I'm already screening papers based on titles, but like I don't know, we just get a broader exposure to more papers. Maybe Hugging Face is always going to be really vision biased. I guess I feel like I consider AK originally to be like a computer vision blogger or computer vision Twitter more than just like generic ML or AI Twitter. So let's go over here and maybe if we go to linguistics, we can get something. Well, let's see, computation language ML. Because people do come in and they ask, "Oh, Matt, you just read vision." It's like, well, I mean, I do vision, so like that's a lot of what I'll read, but it's not like it has to be that way. Okay, like I said, I really don't want to read agents. I Maybe I'll feel interested later. Okay, this is cool. Let's see when this was submitted. Ugh, it's not optimized, so we could be clicking into anything. I don't recognize the names, but why not? Um, Diffusion LLMs, so there should be something I can kind of understand from it, maybe. Uh, This looks like a position paper based on the title. Oh, thanks, Sam's. Okay, so let's conditional memory via scale. We'll look up. So I realized an incognito tab doesn't really fix my problems where I don't want to accidentally, like, I don't know, show something in my search history I wouldn't like to. I need to just make an account that I only open when I stream. That's probably the solution. Okay, we'll look at this one. Let's see, anything else? Token compression, that's relevant to other stuff that I like. Let's take a look at that. Okay, that's a couple of language things. I get that I picked them all from the same day, but I mean, hey, there's a lot of papers. And we try to use the Hugging Face as our signal for like quality, right? So this is just trying to find stuff at this point. Oh my goodness, look at this. AutoML 2018, it says. Are we misunderstanding that, or is this like like if I click into this, is this a paper from 2000? It is. Cool. A Raytheon paper from 2018 at the top of the 2026. That's the beauty of arXiv. You really never know what you're getting. Sometimes you could be getting a AutoML paper from 2018. Neat. Okay, some of these seem like really, I don't know, niche, for lack of a better word. If anything catches your eye, let me know. Hey Matt, what is your opinion on the current PhD funding situation? Do you think it is improving? I actually don't know. I should ask people if they think it's improving. I'm just far enough removed from it to where like I would notice big things. Like if admissions were better this year than last year, I feel like I'd notice, and I feel like they were the same. But I wouldn't know the little things. Like if people are saying their NSF contacts or their NIH contacts are feeling better, like I can ask. My gut feeling is no. We'll just have to wait a few years. Yeah, Sam says it's not improving. So that's at least 2 data points. My gut, and then Sam seems very confident. So take that for what it is. By the way, if you're new to this stream, we're going to read some papers. We're just trying to get some of those papers open up. Hey, check this out. Intern S1 Pro. That sounds, I don't know. It'll be something. I'm trying to get an ML paper, by the way. If you guys have an ML paper, and by an ML paper, I mean something that's not like CV or NLP necessarily. So we're checking the ML space. I'm not going to open to the single author thing though, even though flow matching kind of catches my eye. I'm not touching that. I don't know what I'm looking for here. Let's click another day and see if any of the top, like the final submissions of the day sound for solo author. I don't think so. This is just self-driving. That's not what I'm looking for. To be fair, I don't know what I'm looking for. End-to-end efficient RL. But let's just glance at institution as like a quick filter. Okay. Kind of curious what they mean by the end-to-end RL. Oh wait, no, my eyes like glazed over that one. I thought it was saying continual learning. What was I looking at? Oh, my eyes glanced onto this one. Similarly aware, a mixture of experts for data efficient continual learning. Okay, never mind. I don't really want to read that one then. Here, I don't want to keep scrolling on papers. You already have a few open. We grabbed some from arXiv, especially to have a few language things. We grabbed some vision stuff from Hugging Face. We can glance and see if there's a couple more down to, I don't know, getting a little lower. High resolution crops retrieval for efficient VLLMs. I said VLLMs. They said VLMs, whatever. I want to look at that one. I've been doing some work similar to this, and I'm kind of curious how it compares. Especially, ooh, there is a paper I wanted to see today. Let me pull it up. What's it called though? Something diffusion. Similar idea, by the way, to that. I just can't remember exactly what the actual name is. So hang on, I'm pulling up Slack on a different device because I know that I put it there. Foveated diffusion, that's what it is. Foveated diffusion. Yeah, okay, that's not opening the right thing. Why does Google love opening the arXiv HTML? Does anybody else like arXiv HTML? Because I don't. What was Sam's was conditional memory via scalable lookup. Okay, so we can do that one first. I'll move that to like this top position. think we can come back to this in a minute. This is plenty of papers. We can speed run these, see if there's a deep dive here. We can afford to be picky. Let me just check my scene real quick and make sure we're in shorts mode. We are just outside the bounds of shorts mode. So this is probably, yeah, this is a good fix. 95 for this guy. I wonder what format that is that it's 95. I try to remember the percentages for the different paper formats. Let's just open everything though. So let's put our Hugging Face tab at the end, and let's open the papers real quick, because this is just annoying. It's nice to get it out of the way once, so I'm not going back and forth with my OBS the whole time. By the way, okay, so now that I have a few people here, about the stream schedule. I don't know how many of you are here because it was scheduled, because last week it was scheduled, and I'm not sure if it was because I was low energy or if it was just bad luck, but I ended up with like 1 viewer, 2 viewers, and I kept going down to 0. And so that's not that I think scheduling is bad. I think the important thing is to be consistent, right? But it does make me think that maybe I scheduled a time that wasn't ideal. I would stick with the time though, in spite of that. However, there's a few other things. So somehow I'm constantly going live at the time that I have like the least motivation to be live, and that's not fun. But that's like doable. It's not like the end of the world. The bigger thing is my kids' soccer games keep rescheduling themselves on top of the stream. And they're never going to be on Sundays is the thing. And so what I'm thinking is it might make more sense we kill every bird with one stone, and we move the regularly scheduled stream to tomorrow, like 1 hour later. So I'm not like having to caffeinate myself to feel like a person at 8 a.m. Instead it would be like 9 a.m. And then I'm not worried about like every time I get a schedule adjustment from kids soccer. It's just like safe. And then I can actually do a few of them in a row instead of like here. Like I think this is the 3rd week in a row at this time slot, right? Or is it the 2nd? Like was 2 weeks ago? I'm losing track of time. Was 2 weeks ago the time that I rescheduled? Basically, I know that it's not fair to say anything about the success of the stream when I don't keep the schedule. But unfortunately, this is a schedule where my only IRL commitment, the soccer game, keeps putting itself right on top of it. And so I think I want to move to Sunday just to head that off. I don't know. What do you think? Let me know in the chat. Have I been keeping good track of the chat? Sam says, yes, please, Sunday 9. Okay, cool. So that's at least one person like Sunday 9. Yeah, so that's my plan. I think go live tomorrow. That's just so much easier for me to be consistent. I don't know why I thought it made sense on Saturday. I think in my mind it was like, oh, I'll get everything out of the way, the stream and then soccer, and then I'm chilling. But like, I enjoy this streaming, and like me saying I'm gonna go live at 8 is basically just like asking my wife, hey, you want to like wake up with the kids at 8? Whereas like 9 is like a way more natural time. I can feed them breakfast before I go live. She doesn't even have to wake up. So I think it's just better. I don't think she's up now, by the way. I did get them breakfast before. They woke up like just in time to where I was able to get them their stuff, which is nice. But yeah, okay. So I think 9 it is. Anyway, so let's read some papers. Let me pull up my timer. Let's full screen my timer. Let's make it as small as it can be, though. 1 minute, and where's the notepad? Notepad. Okay. For some reason, this is fun. It unzooms every time, so we gotta redo the zoom. Okay, there we go. Live soccer game analysis of CV. Yeah, if you want to see me analyze elementary school soccer with computer vision, it's crazy. I've been told it'll get better as the season goes, but right now it's basically like rugby in the sense that like the ball is in one place and 5 kids from each team like go up to it, and they're kind of just like bumping each other, and maybe a couple of them that are a little better are like kicking the ball. But you're mostly just watching a lot of kids watch the ball. For me, it is 6 p.m. I guess it depends on time zone you mean. Demir, yeah. Hopefully 7 p.m. isn't too much worse, and I'll never be like late. That is, I think it's really important that I say the time and I'm live at the time. So when I'm saying 9 a.m. Sunday, I mean it would actually be the 9 a.m. I don't know. If I feel like I'm getting great traction at 9 a.m. from people that are like falling off at 10, and it's like, oh man, I would have been there if you were live at 8. Like, I could be live at 8. because I do get energy just from viewership, right? Like if people are watching, I can feel good about it. It's more like when I go live at 8 and then there aren't people. Like last week, I think it dipped to 0 a couple times. I just killed it at 9 a.m. because I was like, okay, no one's here. Um, so it just depends. I do think I'll try 9 a.m. tomorrow. I am open to moving it back up, but we will see. Anyway, let's read some papers and then we can talk a little bit more about the state of the stream in a minute. Okay. So is this no, this is Sam's paper. This is not the top one of the week. Okay, let's start the timer as soon as I breathe. Conditional memory via scalable lookup, a new axis of sparsity for large language models. Okay, I want to see how this memory is designed. Let's skim the abstract to make sure that we're not missing things. They call it Ngram, which is the conditional memory. Modernizes Ngram embedding for O of 1 lookup. Okay, so it's some kind of Ngram, like on the actual language tokens. They scale it to 27 billion parameters, achieving better performance than the MOE baseline. So is this a replacement for the MOE layers? While the memory module is expected to aid in knowledge retrieval, they observe even larger gains in reasoning tasks. It relies on early Eulerian stack reconstruction. Okay, let's try to look at this diagram. So the module augments the backbone. So it's a block within each layer. So yeah, it replaces, well, I still see the MOE. So it kind of helps the layer-wise MOE, I guess. Context-aware gating. So it looks like it's literally an Ngram lookup. So I wonder what the innovation is that they use to make this efficient, because it looks like, and I'll explain this when the speed run is over, it's just Ngrams within the model. So I want to see a little better what's going on. Okay. So for those of you that don't know Ngrams, an Ngram model would basically take a huge corpus of words and it would form like a probability dictionary kind of, where like basically it would have the probability of all pairs of words. Those are like a 2-gram is 2 words. Like the great is 2 words. And so there's a certain probability associated with that in the corpus, meaning over all pairs of words, the great appears a certain portion of the time, right? And you can probably imagine there's tons and tons and tons of pairs of words. And so maybe you're an exceptionally high probability pair of words if there's like, if you happen over like 0.001% of pairs, but even that's probably a bit high. But the idea with Ngrams is you could define like a certain Ngram window, and like let's say that I already have a word the. Well, actually, I think if I remember, 2 grams would be like the great. Like, what's the word that happens after the great? Or 3 grams Alexander the Great. What happens after Alexander the Great? Because I believe 1 gram is the probability of what happens after the one word. This is the same idea behind how something like blue is evaluated, by the way. You take your windows across the words and you look at the probability of specifically like that chunk of words. And so it's very like statistics heavy. It's also not very flexible to the actual meanings of the words. So it's kind of like what some people will pretend the LLM is in the first place. Like, oh, it's all statistical lookup. Like the Ngram is actually statistical lookup. It's just how much do these words literally occur in this order in this corpus, and we simply control it by defining a length, right? It gets more random the fewer you get in terms of like the number, the n, right? Like there are way more pairs of words than there are triplets. Just saying we're going to do a 3 gram gives it a little bit more structure than saying we're going to do a 2 gram. But at the same time, you also run out of data as you increase n, and you start to become a lot more biased to however big your corpus happened to be as you get to like 3, 4, 5, whatever values of n. So I'm still kind of curious here because it looks like we do some kind of hash embedding of all of our Ngrams. And so I imagine at train time, we just have kind of this hash table, and then, because we're doing some kind of hash embedding, and then we get our 2 grams and our 3 grams. We concatenate this representation. We pass them through separate linear heads, and then we do a dot product of some hidden state. So this essentially looks like an attention inside of this Ngram, right? Because we have this embedding, we do a linear projection, we have the input state, we do, and we do the scale dot product, and then we do this concat operation, then a convolution. So it's not quite attention, but it is reminiscent. Is this convolution like a text-wise convolution? Is that making a comeback? Are we going to do like a conv over neighboring text? Sorry, I know this isn't a speed run. I'm just very surprised to see Ngrams suddenly. So I am just going to sit here with this for a minute. I guess maybe we can call this our deep dive. Let's see. Ngram at training. All to all, is this just telling me, yeah, okay, an all to all, oh, an all to all communication primitive is employed to retrieve active embedding rows across all devices. It's kind of interesting. That would be a little expensive. Especially, I know DeepSeek has some of the most efficient training infrastructure out there, and so a little interesting that they think this is worth adding the all to all, which probably adds non-trivial latency to their pipeline. Inference phase. Ngram tables are offloaded to host memory. Okay, yeah. At inference, we've already built the table, so we don't need to worry about it. Whereas at training time, I guess we're building the tables, right? I still need to look a little closer. There's something I'm missing about this. I think the nature of the hash operation would be a good place to start. Okay. So while Ngram models typically operate directly on tokenizer outputs, standard subword tokenizers prioritize lossless reconstruction, often assigning disjoint IDs to semantically equivalent terms. To maximize semantic density, we implement a vocabulary projection layer that collapses raw token IDs into canonical identifiers based on normalized textual equivalence, lower casting. Okay, so in practice, this process achieves a 23% reduction in the effective vocabulary size. Do we really care about just a 23% reduction, though? What is that necessary? For a token of position T, we map its raw ID X sub T to a canonical ID to form the suffix ngram. Yeah, why do we need... Like, I would get it if it was a huge reduction in vocabulary size, but why is it worth remapping the token IDs for just a 23% reduction? I guess it's just important for it to be super semantically dense, and so we want to sort of remove the space of just like meaningless vocabulary size. I don't know. I'm curious if anyone in the chat has any thoughts on why we would need to do that. Anyway, multi-head hashing. So they have a hashing-based approach. Yeah, because parameterizing the combinatorial space of all possible ngrams is intractable. Like I said, there's a ton of combinations. Like, even if you had the most probable two-word set in the corpus, it could be like, it could happen a vanishingly low amount of the time. There's just so many combinations of two words. So they have k distinct hash heads for each ngram order n. Each head k maps the compressed context to an index with an embedding table within an embedding table via a deterministic function. In practice, it's a lightweight multiplicative XOR hash. They construct the final memory vector E sub t by concatenating all retrieved embeddings. Oh. Interesting. For each ngram order n, are they saying that, like, the ngrams aren't necessarily order dependent? Like, what do they mean? Maybe this is me missing a language thing I should know. But what do they mean for each order n? Oh, or do they just mean for each value of n? Is that what that term would mean here? Yeah, I think that's what they mean. I think they just mean like there's for each, like for n there's a head. Wait, but it says k distinct heads. Oh. So like 2 grams has k heads. 3 grams also has k heads, but like they're all separate heads. I still don't quite understand the rule of k, unless it's just to inject some sort of like extra learnability, basically. Although is k even learnable? Because like what exactly is k? It says each head k uses a deterministic function, so I don't think k is learnable. And what is this function? Oh, they say it's a lightweight multiplicative XOR hash. I'm not going to spend the time to learn exactly what this means. I should probably just know already, maybe, but... Or do I want to know? Would that be helpful to our understanding of the paper if I knew what multiplicative XOR hash is? Oh, okay. It is just a hashing thing here. I'll put it on the big screen. Combines input data using multiplication by constants, like large primes or random values. So I guess we'd probably take these, not the real token IDs, but the ones we projected into the smaller vocabulary, and we're multiplying them by primes or random values, and then using XOR operations to provide, just to make sure we don't have collisions, basically, in the hash. And so I suppose what makes the different heads different is just that these random values or these primes are different per head. Oh, here, quick question. Sure. Actually, I'll answer that question once we're done with this paper, which I think we're actually close. I think I'm close to understanding the basics of how the method works, at which point I'll be happy to jump to another thing. So, okay, actually, have we understood though? These would be the hashing heads, and the heads would give us the embeddings. Where does this really help with like where's the table of it all, right? Because they kind of describe it in those terms, do they not? Ngram tables. Where does this build a table? Is something I want to try to understand. Or are they just saying it's like a table? Like where? Let's see. Okay. Each head K maps the compressed context to an index within an embedding table. Oh. Okay, so they're saying this multiplicative XOR is essentially mapping it to an index within an embedding table, and then wait, so is it the hash itself that we treat as the embedding? I guess that would make sense as long as like the values are scaled appropriately for the network. Like we could treat that hash as a representative embedding of whatever the ngram is. And then we have like our different lengths of ngrams depending on the different parts of the sequence. And then I think another question I have, but I don't know if I'll answer it right now, is would this diagram be more accurate if it was showing Alexander the in addition to the Great? Or since we're doing the autoaggressive text generation, are we always like starting from the right and just building our grams going left? Also, in practice, do we only do 2 grams and 3 grams? That wouldn't surprise me because maybe it gets more expensive the further you go. But this is interesting. I think I buy what they're saying, that they basically found a way to parameterize the ngrams by constructing the hash table basically as like an embedding mechanism, and then doing like linear combinations, this multiplicative operation as well, with the actual hidden state to basically say like we are going to take the actual like amount and likelihood of the occurrences of these neighboring pieces of text, and we're going to index hard on that. The interesting thing is combining this with the conv, which a conv is like before we did attention in LLMs, well, before LLMs, sometimes we would do this convolution mechanism, right, where we would slide a conv filter over a sentence. And so if it was a 3dim conv, if it was a kernel size 3 on a 1D conv, so there's no other portion if you're a vision person, it's just like 3 by, there's nothing. So it would be the module augments, right? And we'd have a conv on those weights, and we get some embedding of the module augments, and then we get some embedding of module augments da. And so the thing that fascinates me the most about this is we're clearly kind of doing that same idea again, right? Where we have an embedding for the Great and for Alexander the Great, and we sort of combine those. And then again, we do what would essentially, I imagine, be like a sliding window conv. And so we have locality bias here, we have locality bias here. And it's kind of like we're saying like, okay, so the attention is going to be responsible for the long range dependency, but we are going to have this heavy temporal dependency on the ngram. And that dependency is augmented by this idea that we're able to look up the probability of the current thing in the first place. So look up the probability, but huge locality bias on what the probability is, because it's not the probability of the word in the sentence. It's the probability of the word with its neighbors. Then we slide a conv across it. So when we look at it from that perspective, I get that they're saying like, surprisingly, this does even better for the knowledge and reasoning, even more than it does for the, they said it does better for the reasoning for the lookup. Where's the lookup? Let's go to that table so I'm talking about the right thing. What are some of the data sets which would prioritize the lookup? Let me just go to where they make the claim and I'll take their word for it. MMLU, okay. Let's see the MMLU. Okay, yep, so they get some improvement in the MMLU, but they also get broad improvement across all kinds of reasoning, broad improvement across math. I guess this would be nice in any task where the model just struggles to reason locally as much as you wish it would, which might be all tasks. Let's see. Oh, I'm getting a lot of messages. Do I need your help, please? Do you know very good resources for how to properly write a thesis? Bro, you talk so fast. Chill for a second, please. I think I probably will keep the pace of how I talk the same, but here, okay. So I think we understand this paper, by the way, or at least I do. Feel free to ask questions if you feel like you don't. I will start answering the questions in the chat I've been ignoring a bit. Is it fine if we marry during PhD or after? I think it's fine for you to marry during PhD. I married during my undergrad. So maybe I'm not the best person to ask. I have a very different perspective on this than a lot of people would. Um, yeah, I think getting married is awesome. I think timing is mainly about what you want with your life. For me, I think being married helped me focus a lot. Like, it wasn't like I was just in the PhD to like do whatever, you know. I was there to get in and eventually get out. Having kids helped with that a bit too, right? Like I couldn't just stay there forever, uh, losing money potentially if I didn't get internships, right? And so I always had that stress. On the other hand, it kind of did push me away from other goals, right? Like I could have tried maybe to do the postdoc grind, to maybe try being the operative word because this is hard, but to maybe try to eventually do a faculty grind. That would have been super duper hard to put the kids through. And so it was like, okay, I can go to postdoc and keep making no money, and that's hard for my family, or I can go into industry and make money, and that's a lot easier for my family. You know, they'll see me the same amount of time either way. I work a lot regardless, but at least in the one case, they can have nice things. So, yeah, it really depends on you. I think getting married is great, but everybody's different. So that answers that question. How to properly write a thesis. Edmund, in our this field at least, like the ones I'm talking about, computer vision, natural language processing, in the US, it's a little hard for me to comment on Europe or China or India because I haven't done a PhD there. We tend to do what a lot of people would pejoratively refer to as staple thesis, where you write a bunch of papers, and once your advisor feels like you have enough and they're happy with it, they say you can graduate. Staple those papers together in a thesis. They don't say it like that, but that's essentially what you do. Um, you take your papers, you make them into chapters, and you add an introduction, you add a conclusion, you add maybe some other supporting stuff, you add the table of contents, you add, you know, whatever satisfies your university's definition of a thesis. This is exceptionally common, at least for American technical PhD. I don't know how common it is elsewhere. Perhaps in other places they still do like a real thesis. But that's also why you'll see exceptional researchers whose thesis has like no citations because people cited the original papers that had the work, and they tend not to cite so much the thesis. Not to mention, a lot of our work tends to be open access. We put it in an archive, but a thesis does tend to live in the university's library or with whoever their partner is for thesis publication. And so it tends to be less accessible. You're from Germany? Yeah, Edmund, I can't comment on Germany for sure. I would guess that they do staple thesis as well, at least in technical fields. And so how to write a thesis is basically do great research and publish it. Even if it's not do great research and publish it, the thesis would still have your research, right? And so um, the answer is still do great research. The thesis kind of writes itself in a technical field after the research is done. Scope a good problem. This is where your advisor is important. Work really hard on that problem. Make progress. Your advisor can tell you if you're making good progress. The writing part of it, I think, is not so tricky, right? There's a template which defines basically how you write it. A thesis has an introduction, a thesis has chapters, a thesis has a conclusion. If you're in like ML, those chapters will tend to be, you know, individual methods you proposed over years that moved you further and further towards the goal. Hard for me to comment on other fields, just not as familiar. Okay, worship money. Oh, how old are you then? Bro, you look 23. Oh, I'm glad you think I look 23. I think I'm like a Norwood too, though. Like my hairline. You should have seen my hairline at 23, man. Or, uh, gal. What's like colloquial? See, that's part of the problem with my language. Like, what would I call like a woman that sounds like familiar? I shouldn't say man, right? Because I don't know. And also, I want to unscrew up the channel stats. But I look young. Yeah, I'm not 23. I'm closer to 30 than I am to 20 by a bit. And I'm telling you, my hairline was lower when I was 23. This thing is stressful. It's gonna be gone by the time I'm like 35, I swear. Okay, so nationalist Catholic. Oh, I gotta be more careful reading people's names. Worship money, go. Um, just ask them if they know the difference between objective and subjective truth and they fall apart. Uh, Testosterone typically makes your hair fall out more. Person whose username I shouldn't be reading. But that depends, and it depends on the type. Like DHT, is that the name or is it just free testosterone? Hang on, free testosterone versus DHT. I think it's free no, it's not. It can't be free testosterone. It is DHT. Hang on, it's been a minute since I was too obsessed with hair loss. Yeah, DHT is the one that's one of the ones that's typically making all your hair fall out. Not if your level is at jeopardy to begin with. Yeah, interesting. I don't know how interested I am in arguing with hormones for too long. One thing I do wonder is I've seen people where like your hair can go gray and not gray. And so I think my stress is pretty unhealthy as it is, but it would be super cool, I think, to like have like a really stressful time with like some crazy deadline maybe and like see my hair go gray and then like get unstressed and then see it go back. That's like on my bucket list. If I could make that happen somehow before I don't have hair anymore, that would be like that would be pretty sweet. Um yeah, DHT, I'm suffering as well and I'm 24. Yeah, a lot of it's just genetics. Um Anyway, let's be careful talking too much. Don't want it to become a hair loss stream. Are LLMs a good field to do research on? Yeah, I mean good. Good is subjective, right? I think when you're doing like LLM research, it's typically going to be quite empirical, which might not fit a lot of people's tastes. Um, and when you do it academically, like not in an industry lab and you don't have access to as much compute, you are going to do a lot of research more on the later end of it. Meaning like you'll take a system that's already trained and maybe you'll train it a tiny bit, or maybe you'll just evaluate it. And maybe that's not as interesting to you. And so if you're looking to get more like into the weeds and train things, that means either internships or it means research something other than LLMs. Let's see. Gray is normal on the sides. How stressful is your job? The banana chips job's pretty stressful. But it's not stressful like in a bad way necessarily. It's stressful because like I think a lot of us, especially in the last 6 months, um, are getting the sense that like a lot of things are changing. And in some ways it feels like some of the way we do things right now is the last time we'll ever do them that way. Regardless of what happens with these tools. Like already there's things I can do with code agents that I just couldn't do myself 6 months ago. And so I think a lot of us feel this kind of urgency. I don't think I'm to the point of like John Barron maybe, who will be like, I'm preparing for the singularity sort of. Like I don't quite feel that. But it does feel like a special moment and like regardless of what happens on the other end, it's really important not to let it pass without like doing my best to do something. I think that's what's going on. Bingo, absolute truth, empirical, now do objective truth. Um, Objective truth. Objective truth versus subjective truth is kind of fun because the individual person asking it has their idea of what both of those things mean, which is different from the idea that someone else has in their head when they ask the exact same question, which is just a funny commentary on the question itself, I think. And I'll let you sort of ruminate on what I mean by that. I do think, obviously, that there's objective truth, right? Like, there are things that are definitely true. Do I think I know a lot of those things? Uh, I don't know. I don't know if I feel like I know a lot of those things. I feel a lot more confident than I should in things that I only know are true due to sparse observations. I think I get really confident in some of those things, and maybe I shouldn't, and it makes me wrong all the time. Now, practice and principle. I think I'm not so interested in the big theoretical conversation around these things. One thing that I do think is kind of interesting, there's an idea that you'll see in ML research a lot, um, where occasionally theory ends up talking with empiricism. And those conversations are really productive. I'll see if I can show you what I mean actually before I read this paper. A lot of really toxic conversations, I think, when theory folks and empirical folks end up talking. And let's see if I can find this comment. I actually want to highlight one particular comment I saw in the thread. Okay, yeah. This one. Let's see. Okay, this one right here. I don't think there's anything strictly wrong with black box results and empirical papers, but I think that those sorts of papers should be less common. If I'm a PhD student studying ML, then my understanding should be as complete as possible. Otherwise, what's the point of a PhD? We're supposed to have the deepest understanding of anyone on the topic. And I think it's a little funny to suggest that writing a proof for a two-layer network is giving you a better understanding of an LLM than empirically controlling and studying the behaviors of the LLM. And I think that is a hard thing that a lot of younger people run into, but it's not necessarily just younger folks in the field where, like, you look at ML and you see something where it all starts with math, right? I can define everything mathematically, and I can prove a lot of things mathematically. And you see the systems get bigger and bigger. I introduce more depth. I introduce nonlinearity. And you do know, just looking at the system, that surely if I understood all the interactions properly, I could prove everything that's about to happen. But the system's too complex, and as of now, we can't. And it's easy to sit there, though, and still say that, like, everybody that then tries to study the system with the scientific method doesn't have a deep understanding. But I think that's obviously a little silly. Like, if your theoretical study prevents you from even being able to study the system because it's simply too large and too complex and your proofs can't get close, and in order to try to extend those proofs, you have to make like 10 assumptions which aren't actually true of the system you're studying, I think the obsession with theory can become an impediment to being able to understand the system. That's my take. Anyway, let's read a paper, and then I'll glance at chat again. So I was interested in this one, high-resolution crops retrieval for efficient VLMs, mainly because I've been interested lately in, like, how can I shove more pixels at my model without shoving more pixels at it? Basically, how can I show it the pixels I don't care about less? So it looks like what they do is they have instructions that they give to two VLMs. One gets a low-res, one gets a high-res image. They get the prediction on both. An LLM judge says, is the low-res enough? And if it says no, they have an oracle to predict the crop, and then there's some kind of multi-turn conversation. If the low resolution is enough, then they just give the answer. And I suppose what's going to end up happening here is eventually the LLM as a judge or something is going to just learn from just the low res if I ever need to look at the high res. Is that what's going to happen? Am I going to construct a loop at some point within this system? The numbers look okay, by the way. Just seeing a missing bold stuff makes me a little nervous, but maybe these models involve a lot of training and maybe there's a bit of a data difference, and so I'm a little reluctant to judge just based off this table. Although at the same time, if this method actually is multi-turn, like I think it is, and we do low res on the first turn and high res on the subsequent turns, I don't find it very compelling personally. And regardless, I don't think I'm excited enough about anything that just looks like low-res image versus high-res image to look at it for longer. So I think I'm good for now. Let's look at the chat. Math is an objective truth. That's 3 laps so far. Yeah, math is objective truth once we, whenever the assumptions hold, which in ML is, the issue often is overassuming. But yeah, I would agree with that. Math is objective truth. Oh, that is so interesting. You mean like technology is kind of at a breakthrough point? Yeah, Banana, I feel like technology, AI in particular, is, I think we crossed some breakthrough point in the last 6 months or so where, like, at least for me personally, right? And this is where things get kind of personal because some people are saying things about the tools like a year and a half ago that just sounded crazy to me. Because every time I tried to touch them, unless I like really, really babysat them, meaning spent a lot of time on it, I would just get garbage. And the time that I would spend to babysit in terms of like crafting the prompt, in terms of sanitizing the output, or like, going over proofreading, would be more than the investment in me just writing stuff on my own. Part of that could be because I'm known to like write quickly, so a tool that's just supposed to speed that up might not help me as much as it would help someone that writes slowly, especially once you add in the fact that I need to, craft a prompt carefully, test it, whatever. But we're past that point. I can send very, 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 very vague instructions to my agentic pipeline and typically get good things out. And if I don't send vague things, I get even better things out. So we've crossed some threshold. I don't know what comes out the other side of this. I do think that what OpenAI is doing, I think, is a sign, and I don't think it's a sign of what everyone thinks it's a sign of. Um, my take on and what I'm talking about, so I'm not vague posting. Let's find like a news article or something. Okay. So, oh, actually, let me like react to an article from The Verge. Why OpenAI killed Sora. Let's see if I think I agree. Um, oh, I'm not a subscriber. Hang on, let's find something free. I'm not subscribing to The Verge just for this stream. TechCrunch. No, that's a video. And not even the right video. CNET, right? That's a free thing, isn't it? Yeah, they're not even going to make me turn off my ad block, which is nice because I don't really want my ad block off on stream. Oh, but I get an ad anyway. Thanks, ad blocker. Okay, so for those of you who don't know, OpenAI decided to, oh my goodness, that was a jump scare. Okay, yeah, OpenAI also isn't doing ChatGPT adult mode. I didn't actually know that. First off, I don't think about the fact that they were going to do adult mode much at all. Okay, so I think a few things are happening here. I think that so yeah, OpenAI decided to shelve Sora or like shut it down. And what Sora was, if you don't know, is their video generation app. Like Sora is the name of the model, and the Sora app was the app where you could go, give a text prompt, get a video, and do like multiple turns even to refine the video. OpenAI also had this big $1 billion deal with Disney, where Disney was going to give them IP, and OpenAI was going to use Sora to generate video content for Disney. And when this news came out that OpenAI was going to shut down the Sora app, everyone's first reaction was, oh, the Disney deal fell through. Well, it did from OpenAI's side, right? I think, yeah, so Sam is calling Sora kind of a side quest, and I think it's important to give that context. So, right, like we have the two big dogs, let's say, in the LLM space of OpenAI and Anthropic, and then we have like Google, who, when we're talking about like the pure LLM, I would say is pretty clearly like a peg below, and Grok, who probably maybe peg below, except I don't know. I find Grok kind of fun if I really want to know, like if I'm trying to talk memes or something. Like if I see some weird idea, if I want to know the origin of some random niche internet thing, sometimes I actually do go to Grok for that. But Anthropic has never really treated vision like something that matters at all, and they've never had like a video gen app. Google, on the other hand, typically has the best video gen, and Grok Imagine is quickly trying to catch up, right? And OpenAI had Sora. It was led by, I think, Bill Peebles for a long time, who is like the original first author of DIT, which was a 2-author paper he did with Signing. So they had like the edge, right? Like that they hired like some of the top people into Fusion Transformers. They've had Sora since before pretty much anyone was trying to generate video, and now they're shutting it down. And they said a lot of things. Sam kind of calls it a side quest. They are clearly worried about like the IP stuff. Like I don't know if you saw there was a lawsuit in the UK recently, and I don't know why I have the article open if I'm not going to read it. I just kind of am not in the mood. I realize with it open, but this makes it seem like I'm reading an article. But UK had this lawsuit trying to see if like creators could maybe claim royalties in perpetuity if a model's trained on their works. Like there's a lot of like weird copyright stuff going on. And then there's also the nature of the things people may have been using the app to generate, and that exposes a lot of risk. I don't know if you saw there was a lawsuit that Meta and I think also YouTube lost this week around failing to protect children. I think they're seeing that kind of stuff and it makes them nervous. So the adult mode thing I think is definitely probably related, right? Just trying to reduce their exposure to things that don't make sense. And this is a big thing that I was saying a year ago, I think, is I was very skeptical of the progress of LLMs and this singularity idea. And what I would tell people is clearly they don't believe in the singularity if they're chasing pennies trying to make porn, right? Nobody that thinks the singularity is imminent is going to take their like $1 trillion scaling machine and try to consume the few $billion industry that is porn. Not that people don't like porn, but rather people don't like paying money for it, right? I'm not going to try to argue the financials of pornography too much, but that was always a sign to me that they were looking for pennies on the ground, basically, and a sign of maybe pessimism internally. I think they're signaling the opposite with this. They're showing that they're not tolerant to the risk, first off. But I think the other thing with shutting down something like Sora is, it takes a lot of tokens to generate video. A 1080p video, It's possible that these top labs are compressing way more than I think they're compressing, but I think that they're probably not compressing any more strictly than like 32, maybe spatially. And probably no stricter than like 8 temporally, if we're talking about a causal VAE, which granted some of the top labs maybe not using the causal VAE. But if we even just pretend, like, let's assume like a 32 FPS video, wait, oh, 12, this should be like 12 something, right? Wait, 1080p, no, 1920, there we go. I'm like, what the heck? We're talking about 8,000 tokens for like 8 frames, basically. It's a lot of tokens just to get out a few seconds worth of video. And it's a lot of GPUs. You can make a lot of money generating code for people. If you're doing the code generation well, it's hypothetically like a $1 trillion plus dollar business. Video gen isn't. You could be the provider for all the videos generated on Meta. Meta as a company is making like 160 billion, right? That's the revenue, isn't it? Meta revenue. Hold on. Meta revenue. 200 billion. Okay, sorry. Up from 160. I can't have every new number in my head all the time. 200 billion. Code is not a $200 billion business. Your per token efficiency, your overall industry scale, the powers of going to enterprise and to enterprise users versus just trying to sell videos to whomever. Even the biggest corporate partner, Disney, that's a $1 billion deal. That's a lot of money to you or me. Is it a lot of money relative to what it costs OpenAI, at the cost benefit? So I think that's where a lot of the writing on the wall is. Let's see. Math is the limit of language itself. It doesn't have anything to do with AI. I mean, math has some things to do with AI, right? If it's the limit of language itself, if it's the limit of all idea, if it is the way I can explain everything happening in my brain, right? Then it also essentially tells me how I should do AI. You're underestimating degenerate gooners with money. I don't think I am, Nationalist Catholic, underestimating degenerate gooners with money. I think the amount of money in that space still pales in comparison to the amount of money that you can generate by being able to build anything at any time by vaguely imagining it and like snapping your fingers. I use the free versions of Claude and GPT, and I generally don't find it that useful for more complicated codes. It's just me. Yeah, there's a drastic difference in the paid versions arena. Yeah, I like the free stuff for one-liners and casual things. When I'm doing still simple scripts, I can often go to the flagship instant mode, like no thinking, no agent. For somewhat more complicated things, I can go to some kind of thinking mode, which might churn for like 20 minutes on the pro model. For really complicated things, it needs to be paid and sitting in my code and have hours. So that's where you'll see the difference. You're overestimating your own power. Subjective truths are relativistic. Okay. I might... Not a super big fan of the vague posting. Okay. Minor U diffusion. Let's read a paper. I think I'm caught up on chat. Rethinking document OCR as inverse rendering via diffusion decoding. Okay. So we want to recognize the characters in the documents, and we're reimagining as an inverse rendering problem. Okay, unified diffusion-based framework which replaces autoregressive sequential decoding with parallel diffusion, denoising under visual conditioning. See, I think I know what this is trying to say, and I'm going to try to get to it in the 1 minute. So if I can find a good visual diagram, let's see. So overview of the document OCR inverse rendering process via different decoding methods. It maps a 2D document image to a 1D token sequence for decoding through autoregressive and diffusion-based methods. And so I think that what I think is that they're going to try to render a region, and if it renders the way that text should render, they can identify it as text. But that, as I say that, it doesn't quite make sense. I feel like this is one where I'm not going to hold it against myself too much, but the 1 minute, it would have to be closer to something that I'm really familiar with, I think. So let's spend a little more time properly to try to understand a little bit better what's happening. Left to right causal generation is an artifact of serialization. Sure. Diffusion-based framework to replace the autoregressive sequential decoding with parallel diffusion denoising. Okay, so yeah, sure. We want to process all the parts of the document in parallel, which the diffusion denoising would allow us to do. But okay. Are we saying that this is specifically doing the document OCR with the VLM, and we're just going to replace the autoregressive decoding we normally have in the VLM with the diffusion decoding, and that's all it's telling me? Because in that case, I don't feel as bad for not understanding, because I think the way that it was phrased was like bound to mislead me a little bit. Overview of the document OCR inverse running process via different decoding methods. The model maps a 2D document image to a 1D token sequence for decoding. The model. And in this case, what is the model? Is it just a VLM? Wait, no, that doesn't make any sense. It can't just be a VLM. I mean, the VLM is what we're doing on the, like, the VLM would be processing these AR tokens or processing the diffusion tokens. So what is the model for this mapping? This is also a thing too, where like I don't do any OCR, and so it might be that if I did OCR, I would see this and I would immediately know, like, oh, this is what model is, obviously. If one of you knows OCR and can tell me what the model would be versus the decoder, that would be really helpful. So I'm not just flailing about here trying to find this detail mentioned. Okay, so there's some kind of VLM, some SDAR 1.7b chat. And this is, I mean, that would be like so is this like a small diffusion head? Like, do they take the 1.7b model and then train, this is a 2.5b model, so then do they train an 800 million parameter diffusion head to do the denoising on the tokens that the model is mapping? Is that what I'm seeing? It's not how I would construct the diagram if that's what I was trying to convey, which is why I'm worried that that's not actually what's going on here. Here, let's see. Okay, no help in chat. No help in chat makes me wonder if we're not too interested in this paper, and so I should stop trying really hard to understand OCR. This is also making me regret not having known OCR in the first place, though, because I could pull it up on stream at any point in time and then feel embarrassed that I can't immediately understand it. Yeah, if nobody's expressing a lot of interest, let's move to something I'm going to do a better job with. Like the world model. I opened a few world model things. Here, let's breathe, water. Okay. By the way, Arena, I wasn't saying that you just like have to give Anthropic or OpenAI a bunch of money, but it is just a fact that like you're going to get way better performance in the paid tier and with more tokens than you would on the free tier. Luckily, if you're with university, I think most universities will have some kind of benefit with Google or Anthropic or OpenAI to give you access to some amount of tokens on some tier. And then you can get a lot of what you need on the cheap tier, like on the $20. I think I know a lot of people that mostly stay in that budget. Which it sucks to say, just spend $240 a year on this. I think these days, though, you get out a lot more than you put in. And you can put that time to better use. I think especially if like you're already spending money on food to save you time there, right? Like, oh, I'll, spend $10 to go get Sweetgreen instead of meal prepping my own salads once a week. I think that the time savings with the $20 OpenAI subscription far outstrip the time savings in other things that you might pay for without thinking about it so hard. But again, not trying to comment on the specifics of your financial situation. I also know that if we're talking about non-US, I actually don't know. I don't know if there's regional pricing. And so I might be telling you to spend an outrageous amount of money on this, and that's not my intention. So everyone's situation obviously is different. Okay. Towards a comprehensive interaction-centric evaluation for world models, this makes me think hopefully we're doing something with robotics, although maybe this is also looking at just the controllability. So the ability to faithfully reflect how interaction actions drive state transitions across space and time. So what exactly are these interactions? So systemic prompt sweep pinning, spanning diverse interaction levels and scene types, and agent-based evaluation framework that quantifies world modeling capabilities by measuring the impact of interaction actions on both final outcomes and intermediate state evolution trajectories. Okay. So let's look at what these interactions look like. Okay, this is a bit small, but I think I can see a level 1 interaction is just essentially a frame and a prompt. A level 2 interaction specifies some kind of action. So level 1 interaction, there's nothing happening. Level 2, there's some kind of action. Level 3, there's many actions. All of these, though, seem to be specified in prompt space. So I think I was right about that in the first place. Well, except the interaction is not multiple prompt. It seems to be interactions are just described in a given prompt, which is, I want to hesitate to say it this way, but not as exciting as what I think I was hoping for from this kind of thing. I think I was hoping that you would prompt and things would start to happen in the video. And at some point in time, you could prompt to introduce some more control, and then it would have to respond to that, right? That would be like interaction in my mind. But it looks like this is just like we define some interactions in the prompt space in here. I will break the immersion of our shorts just to so everyone can see the model well. Yeah, so we're giving the condition as an image always, and also a prompt, which I don't know if I'm a fan of image conditioning as always support. But we give a prompt and then we describe the interaction and then it has to do something with that. Although they did describe an agentic pipeline, which that would make me hope that we can chain prompts. What I'm worried is that agentic pipeline actually just means like I have a lot of models and they'll have different jobs, but they operate, you know, one after the other or like in parallel at one time, which is fine. But to me, that's not an agentic evaluation pipeline. That's just several LLMs as a judge. I don't think I want to spend more time on this because I think I understand what this is. It's a slightly less exciting version of the thing I think I already said I wouldn't be too excited by, which is like we're interacting via prompt, right? So it's not even, I was kind of hoping that there would be maybe some robotics component, like maybe I would have a video model trying to predict the future for a robot that's acting, and I would mess with the scene of the robot, which should change its imagination of the future, and I would see how it responds to that. Granted, I do know that that's a bit far ahead of what we're doing with world models right now. Part of why I wanted this to be that. What this is fine. You know, try to measure how well the world model can handle. In a sense, it's basically prompt adherence, right? How well can it handle just complicated actions happening in prompts? So in that sense, it's measuring the compositionality or the instruction following capability of the video model. This is why though, like when we say world model, I think I'm just hoping for a little bit more than just a text to video model that follows instructions really well. I think a text to video model that follows instructions really well is a very important part. Yeah, see the final agentic score is just weighting the evaluation of multiple judges. Yeah, just the different judges compute. The different judges give you scores, you average those to get the score for the judge, and then you weight those to combine them. So yeah, I think a text to video model that can follow instructions and an image condition one at that is definitely like a key part of any world model system. But by itself, I don't think that's what I mean when I say world model, or what a lot of folks that debate world model like Yann LeCun or Eric Jing mean when they say world model. Okay. Did they change anything about the architecture of the VLMs? What do you mean? In that last paper? No, that was just evaluation, and they were just using off-the-shelf vision language models to do the. Yeah, they didn't change the architecture. I doubt they even tuned them. I mean, we can open it back up if you're morbidly curious. We can see where they define the actual judges here. I'll put it on the monitor. Yeah, we can just go find Alibaba Group. So maybe they're using their Qwen models or their QN models, or maybe they're using something else. We can go see what these judges are. That shouldn't take too long. Let's see. See, they define the okay evaluated model. Okay, so they evaluate all these text-to-video models that are pre-trained, right? Hunyuan, OpenSora, TDV Turbo, Image-to-Video Matrix, WAN 2.1, WAN 2.2. Let's see, the evaluation protocol. They define their Omni whatevers. Implementation details. Where are they going to tell me what these judges are actually? Oh my goodness, this is a crime. This is illegal. Don't do this to me. Never do that. I'm not rotating that, by the way. I'm here just to see what this is the section where that should have been, by the way, unless they put it in the earlier section. Sorry, we're getting QuenVL. This is just for the prompt generation, though. This is just for the prompt generation. And this, okay, so yeah, that's just for the prompt generation. That's just for the prompt gen. What are their judges? What? Only 26 mentions of agent. Surely this should take us to the model itself. Yeah, comprehensive details are provided in 4.5. So let's just scroll to 4.5, or let's see if this takes us there, right? Am I crazy? They never tell us what these models are, right? Yeah, are we not expecting the world model to be something different? I mean, when some people say world model right now, they are just talking about text to video models. That's pretty common. People are starting to use it kind of like as a shorthand. I hope it doesn't stick because, like I said, I think a world model needs to be a little more than a text to video model. Like a text to video model is like one part of a world model, but a world model is capable of more things than just conditioned to video itself. Like I think the fact that it can predict the model is an essential capability of being able to do the things that a world model does. But I think a world model for me is much more about being able to predict the future of given interactions in ways that are necessary to be able to plan and act in one's environment. Okay, yeah, I don't think they say it. We're moving on. And that table that they rotate is just crazy. Have I ever seen that before? Never do that to people. That's like, I don't know. In my authoritarian regime, I think we maybe like give you 200 hours community service for that or something. Because that's just wild. Okay. Speed by simplicity, a single stream architecture for fast audio video generative foundation model. Okay, so single stream as opposed to dual stream, which lots of people have experimented with both approaches for a long time. I don't think that part matters as much. 5-second 250p video in 2 seconds on a single H100. That's, I guess, fast video kind of broke my brain in terms of what can impress me. Let's see if we can tell from any of this what gives them the speed. I can't so far. 40 single stream transformer blocks. Nothing seems too special with me there. Yeah, I don't know why I opened this. Hey Sandeep, how's it going? We are just reading papers, giving them a minute each unless I'm super unimpressed, and then we move on. And with that one, I don't think generating 256p in the time that they gave is actually that impressive. And the details that they gave did not point to anything different or impressive compared to anything else that any of us know. So, moving on. Steering forward process reinforcement learning for distilled autoregressive video models. Okay, so this is with a single prompt, short video, single prompt, long video, multi-prompt, long video. Okay, so we can do things with multiple prompts, and we want to, yeah, what I wanted to know is what they meant by the reinforcement learning for the distilled autoregressive video models. What is the new part of this pipeline? So it's a memory-efficient RL framework for distilled streaming video models. It combines group-wise streaming rollout using a rolling KV cache for efficient group-wise sampling and clip-level forward process RL for solver-agnostic optimization. Okay. So to scale to long videos, they utilize streaming long tuning with detached historical gradients. Furthermore, multi-road formulation paired with uncertainty-based selective regularization is applied. Okay. Can I understand this in the next 15 seconds? This part is simply like greedy video generation with an AR model where we empty out the KV cache sometimes so we can keep generating. The online RL optimization part of it is saying that, what exactly? I run out of time, but we'll see what I can do just with a couple more minutes. What is going on with this solver then? Because this is very simple and like we'll say naive even, but the clip level forward process RL full screen is going to do what exactly? Solver agnostic optimization. Okay, because we're going to take, because in the RL we are only taking our fully generated candidate clip. Except we are then noising the clip, although I'm a little confused because this doesn't have any noise, which makes me worried that I'm misunderstanding. Like, I would normally believe that if we're saying we take the candidate clip and we take a noise clip and we feed the noise clip to a velocity predictor, and we take the candidate clip as the target velocity and we compute the implicit policy, and they told me that this is distillation-based RL, I would assume that the noise clip should be, like, noised. And so maybe that's just like a typo in the figure, basically. But this candidate clip that came out of our memory efficient streaming rollout seems to be going to, by itself, this multi-reward system. So it seems like we're already getting some RL-based loss just on the original candidate clip, while we are also looking at the difference between the target velocity and the current velocity of the new thing. These look like the things we're training, by the way. I believe we're training systems in green. So, like, we're taking, like I said, well, maybe already what was a distilled AR video model? I don't think we're distilling it, though. I don't think we're distilling it. I think the blue, I think, is saying it's frozen. I'm not positive, though, because these greens suggest to me that this is what we're training, right? Like, we are, well, except that they use blue for an equation. So I'm a little fuzzy on what exactly is being trained here, which makes it a little bit harder to understand what's going on. But it looks like there's a reward computed just on the original prediction of our, like, greedy stream rollout. It looks like there is another loss here based on comparing the, I believe the clip, see, I don't know what's flowing here. Like, we have a policy with respect to the target velocity, but I don't know if there's any correction here, because I don't see, like, I don't see V old. So I think we're just getting the new velocity and doing the forward process RL loss based on the new velocity. And then we get the current clip. We pass it to the distilled AR video model, and then I'm missing, because we get a velocity out of this. We could use that velocity to do whatever the current denoising step is in the train pipeline. What are we? Oh, this dashed arrow is skipping the stream tuning part. It's a bummer. This seems like the kind of thing where the diagram is going to be more helpful than the text, but we might just need to go to the text if we want to really know which components are trainable and which inputs are fed exactly to which parts of the model and which things go to which rewards. Here, I think they're just explaining how they design the reward completely. Although this forward process RL loss looks so straightforward, so I don't know. Are they saying that there's a KL penalty in this forward process RL loss, which is not actually represented here because they just show this equation is like a part of it? So are they saying we have this main RL loss, we also have this KL penalty, and this RL loss, like the, man. We also have some kind of visual quality, motion quality, and text alignment in the aggregated reward. See, I would think that this was meant to go to the multi-reward system, because this seems like multi-reward. This looks like a distillation loss. Or I guess it's not distillation because the different V thetas come from the implicit policy. But at least the aggregated reward would seem to have these multiple components. It would seem to be the multi-reward system. And so I feel kind of like I'm getting bamboozled by a diagram that contradicts how the method must work. And I don't love spending tons of time in these papers on stream because I don't like sitting on here feeling stupid and then figuring out that I was bamboozled. But maybe it's still me. So let's try to find where the figure is referenced in the text and go from there. So is this in the intro? Yeah, that's not what we need. Oh, that's the only mention of the figure. And then this is the related work. This is the methodology, but 3.1 is just preliminaries. This is the memory efficient stream rollout. That is not the part I'm struggling with. That part is basic. Yeah, rolling KV cache with frame sinks. They're basically just throwing away the KV cache, except they're keeping the first frame, or maybe even keyframes. If they had a map, we would know for sure. Clip level groupwise sampling makes a lot of sense. Rather than generating G-independent long trajectories from scratch, we auto-aggressively sample the visual history exactly once and freezes KV cache as a shared prefix. So we utilize the memory efficient KV states of, yeah, the model decodes G independent candidate clips in parallel. Oh. These are multiple candidate clips at the current step. And we're keeping some history of the multiple candidate clips. Like these aren't, sorry, I see this and I always think frames, but really we were looking at clips. So the inference engine generated multiple candidate clips. We keep some of these candidate clips with historical context. We don't keep gradients on them, but we do use them so that we have some kind of historical conditioning. I'm not sure how far back these go. That's not clear to me from the text itself. Is it going to, and I don't think it's going to get more clear. We have like a paragraph of text to describe this and very, very little math, which is, I was hoping to see a lot more of the symbols that would show me which parts of the pipeline go where. I mean, this is going to describe some of the losses a little better, but I don't know. I'm almost inclined to click away unless someone is begging me to use it more. What was the general idea of the paper? What exactly do they use the RL for? I was still trying to figure out exactly what they use the RL for. I think one way I'm very confident to say that they use the RL is that they take a candidate clip and they define a reward in terms of visual quality, motion quality, and text alignment, and then they aggregate those and then they use that reward as supervision. And so the idea here is it's like any other RL-based tuning, right? You can take a pre-trained model, you can fine-tune it a little if you have the memory, or you can train a LoRa on it if you don't have the memory. And with a good enough reward, even on a few samples on a few steps, you can significantly move the model in a better direction to generate better things. So I think that's the basic, probably what it does boil down to is most of the heavy lifting is this aggregated reward function, because we see a lot of this in diffusion RL-based fine-tuning anyway. And then they try to mitigate the reward hacking with some uncertainty score and a KL penalty. I was really trying to understand the whole online RL optimization idea, which involves keeping a few different candidate clips in the history. Maybe I'm just overthinking it, though, trying to follow all the arrows. I suppose I can probably sum up that most of what's happening is we get candidate clips. We want to learn a policy to model the way that the original model is doing the denoising, except I don't understand why we would want to do this part. I can understand this part. I don't understand this part. I don't know if I want to understand this part. I guess I want to see how well this does. Oh, and I think part of what we're doing, by the way, in the pipeline, and part of what we're trying to do with the part I don't understand as well, is throwing away parts of the KV cache is necessary when we're doing infinite video generation. Keeping frame syncs sort of helps us remember what's going on, but it doesn't entirely help us remember. And so with this process here, my understanding is we are just trying to help the model do a little bit better in this long video regime. Like follow the history in ways that make a little more sense than what it would naturally be inclined to do, considering we don't have the evicted frames from the start of the video. You know, we've compressed them, it looks like, into some kind of shared context, but we don't have them exactly. This does take pretty much any pre-trained model out of the regime in which it was originally trained, and so all this RL basically is trying to help the model behave well under those different conditions. The condition where we're ejecting frames from the cache, right? That's like the key thing that's going on here that requires any training at all. It's going to be hard actually to evaluate how well this does just from a paper because there's not a lot of good benchmarks for the long video generation. And here what we're going to see, like HPSV3, for example, this is like an image quality metric. If we look at a quality score, I would guess that's like some kind of Qwen image evaluation. Obviously the throughput's good, and so, well, but the throughput's good like because they don't change throughput. They take the distilled model and they simply do their thing on top of it, right? So they don't change the throughput. Their metrics look fine, and they are using vbench long, which I think is a decent long video benchmark, but I feel like I wouldn't really know how they're doing until I look because they mentioned the reward hacking themselves. There are a lot of ways you can do degenerate long video. You can basically loop it. You can loop it, meaning like you can always sort of return to that first frame, which is the frame sync, and just kind of repeat that. Like if I ask for waves on a beach, that's even the desired behavior. The waves just continue to crash. It's like the same thing over and over and over again. And so without seeing the videos, I feel like I'm missing a lot. So maybe we'll try to see if there is a quick demo. This isn't what I think of when I think of long video, right? This is a 5-second video. 5, 5, 5, 5. I can generate longer videos than these in context. I can generate 10-second videos without thinking, just in context, at 720p even. Actually, I mean, on an H200, like sequence parallel with 8 of them, I could generate a 30-second video, all in context, single diffusion, fully bidirectional attention. So I was hoping for long video. I'm not seeing long video. That's a bummer. Sorry, I know it looks like I'm mindlessly scrolling. I'm looking at the times and seeing 5 seconds and just saying I don't care. Oh, although, wait. Am I a little wrong here? Are these different videos, or is this like the first part and then the second part? No, they're different. Bummer. Wait, is this just gonna keep generating them as long as I scroll? Okay, no, we made it to the bottom. It was just because they could be, ooh, longer ones. Okay. Well, I said you could do 30 seconds all like bidirectional diffusion, only no AR. Granted, this is an AR model doing it, and this is 40 seconds, not 30. This I think is exactly what I criticize, where here, let's look at the end state, for example. Let's compare this to this. Oh, you know, actually, in the base model, nothing really happens, but in this model, they're kind of taking apart the tower. When does that happen though? So he's like, this mouse is building it, and then it bumps itself, but then the cat comes, oh, and it vanishes. Okay, I don't think I count that as what I'm talking about in terms of being decent. Okay, this guy showed up. That's interesting. But then nothing happens. It's a lot of video where nothing happens. And I say nothing happens because, like, if all you're doing is giving the AR model like the last few frames, I feel like you can do this. Like, there's nothing about this that isn't just like, there's nothing about what's happening here that has to be aware of what happened here. And heck, this can be handled in the frame sync, right? So there's nothing I'm seeing here that makes me feel like, oh, we actually mitigated the impact of the KV cache eviction. I believe them that they improved the performance on the vBench long. I'm not sure I'm convinced that the vBench long is measuring anything that meaningful yet. Oh, maybe this one's going to change my mind. Here, let's watch this one real quick. I said waves are already something you can loop, but it looks like we're going to get a boat appearing out of nowhere. Soon. I remember seeing a boat. Is it coming? There's going to be a boat, right? 20 seconds, I think the boat shows up. There it is. So that's different. I mean, could you do that without KV cache eviction? Sure, that has nothing to do with the start of the video. You could take these frames and just add a boat. I don't know. Feels like the kind of things I'd expect an RL model to do, which is just kind of mess with the sampling a little bit. It's not like I feel like I can see the ills of KV cache eviction here, and I don't hear. Here, I don't know what the heck is going on, actually. What was the base model doing? Maybe the frame sync wasn't used for the base? I'm not sure. You can just use a frame sync, by the way, even without RL fine-tuning. So it's hard to comment without knowing what the base model's doing, I guess, for sure. Anyway, I think I spent too long on that, because I think I basically kept saying over and over that I didn't really like the paper, the way it was written. I'm not really that interested or impressed by the method, and feel like the most useful parts of the method, which are like the multi-reward thing where we measure the visual quality, and we measure the motion quality, we measure the text alignment, and then we do a little reward. Like that's just a way to tune a model when you don't have compute, and when you're doing the post-training, and you're trying to like prune the way that it samples a bit, or like jitter the weights slightly in the flat part of your lost landscape to find a solution that like is actually more suited to your use case. So let's keep moving. If the video doesn't change much, I wonder how they do those chaotic videos where there's a room and suddenly a tsunami and then fire and so on. Yeah, I think I'm not sure what you mean. You'll have to rephrase the question, and I think I know like 3 different things that you could mean, but instead of answering 3 questions, I'm just going to ask you to clarify a little bit, and then I'll try to answer the one question that you really have. Okay, this paper I was excited for. Let's see 1 minute if we can do it. Multi-hop data synthesis for generalizable vision language reasoning. I'm going to skip totally the abstract because I think I already know what this is trying to say. We want to generate, for those of you that don't know multi-hop question answering, it's basically like I ask you a question where in order to answer it, you would need to go to multiple sources of information or multiple different ideas and like connect those seamlessly to get the answer. So I think they give an example here, which is, so how many dolls is easy, but what is the result of adding the number of complete chairs in the closet first and second rows along the width and multiplying by the incomplete chairs in the width of the first row requires you to first count the chairs in the first row, also count the chairs in the next row, and then multiply, right? It's multiple steps. So it's like instead of how many dolls in this image, it's like how many dolls would this image have if I removed a doll? First, I have to count the dolls, then I can do the math to remove a doll, then I can give you the answer. That's the multi-hop, and it looks like they are synthetically generating that by, I don't see the rule here, but that's essentially what's happening. Is they're going to prompt the model to generate that stuff. So, okay, but they're doing the data synthesis, and so are they using real images and then identifying the categories, and then do they have like kind of a templated generator that generates like a fixed set of problems in order to build? I want a better, that's an overview, but I feel like there's a much clearer way to define this pipeline than what they did there, right? Um, we identify the categories, we segment the instances, we look at the different relationships. Man, category identification, instance segmentation, multi-hop query generation, and ground truth annotation with difficulty calibration. So this is the multi-hop query generation. Are they saying that we're always going to do a perception level hop first, and then we'll do this instance chain hop, and all of the questions are going to kind of be like this? How many visible eyes are on the sheep? So first identify the sheep and then count its eyes. Add the visible eyes on the doll next to it. That's another hop. Oh, so we're going to like, this is like we can repeat these. Like we can just chain them on each other. Does the white paper behind the sheep have readable text? If so, multiply the result by 5. See, this is like a good example of what they get. Oh, or do they do this in multiple steps and then they synthesize it into a final question? Typical visual language training data often does not require complex chains that rely on visual evidence throughout. On hard problems, minor mistakes in any part of the chain of thought can compound into final errors. In contrast, the multi-hop data synthesized by hop chain forms logically dependent hop chains in which later hops depend on instances, sets, or conditions. So it looks to me like we're going to create these like hops based on a template, where the first one is always going to be like we've identified the things of the image, and then we'll just kind of build on that to generate more and more questions that rely on each other, which we can then synthesize into a final question, which doesn't handhold the agent through all the steps necessarily, like super clearly. If I don't get a better figure to show that, I think I'm just going to give up. I mean, this is just saying what I already told you about how multi-hop works, right? How many dots do all the ladybirds have? We first need to identify the ladybirds. Then we need to like find dots on them. Then we need to count them. Then we need to add, right? Like that's multiple hops. I am even more interested in multi-hop in video, but I think the way that they construct this benchmark for the multi-hop in the image provides a good starting point for generating a multi-hop data set for video. So I think I like what they're getting at here in general. These might be the examples, by the way, that I need, and that's why I'm here. Examples of synthesized multi-hop data. In each query, purple highlighted text denotes the instance chain, meaning that the instance required at the current hop can only be identified from instances established in earlier hops. In the corresponding image, we mark the instance regions involved in each hop with colored rectangles, and the rectangle colors are aligned with the I think this is just illustrating more how they construct the data. I don't think we give the model this much handholding, but I could be wrong, right? Like we looked at the examples here, and I think we didn't see anything super handholdy. Which season does C represent, right? These are answers. Qualitative examples of, we show failure cases for benchmark. Oh, alongside. Are they actually saying that this is a benchmark that they don't like and they want to give the model more of the steps explicitly? Because that's kind of the opposite of what I like. Or are they saying if you tune the model on this, you can go back to those baselines and perform better? Is that what they were saying the whole time? Yeah, I think that's what they were saying the whole time. I'm bamboozled, I guess, by my own assumptions about what this is going to be trying to present. Okay, so how many of these can they generate then? Like, how big is this? We evaluate hop chain. First, we test whether adding multi-hop data to our LVR training based on the original RVR improves. Then we examine whether the full multi-hop formulation is necessary rather than weaker single-hop or truncated hop variants. Third, we analyze whether the observed gains align with their central claims about long chain of thought robustness. Okay. So I suppose, though, that they're saying that we can train the model with the hand-holded multi-hop, and then it'll do well even when we're not hand-holding. Although it also looks like, okay, so RLVR without multi-hop denotes RLVR training on the original RLVR data only, and then with the multi-hop means you train on the original RLVR plus the multi-hop data synthesized by the hop chain. It improves by like +1 to 3, it looks like not groundbreaking improvements, but some improvements. I don't know if it improves enough to where I really buy their claim that I don't know. I think I would expect more, at least, except for these are general data sets. They don't all require multi-hop all the time. They require multi-hop sometimes. And so you're improving mainly on the cases that actually do require the multi-hop. What is half multi-hop? Do they have a diagram that shows that and compares it to the full? I get that they're saying they can just omit some steps, and so I assume that that's what it is. And unless I see a visual example or like a table that writes it, I'm going to keep... Ooh, we get some examples here. That's kind of nice. Oh, this is the complete prompt for synthesizing multi-hop queries. Interesting. I'm not going to read the whole thing because that would take really long for the stream. You can look at it later if you're really interested. I think I got what I want from this. Okay. Okay, I can answer your question now. What I meant is that if the size of the KV cache acts as the time window, if I understood correctly, and it makes sense that the next frame is not drastically different from the previous one. Yeah, I think that's a criticism some people have of AR models, is how do you introduce the change? I think the change would have to come mainly from the prompt necessitating that the change is going to happen, right? We wouldn't expect chaotic dynamics from a prompt that doesn't imply them. However, I will say the KV cache is not the only time window in models like that. They also had the frame sync, and so they're constantly keeping the first frame in the attention to kind of like ground it with whatever's originally generated so it doesn't go too far. And they also had in their diagram some like context compression of the historical frames. And they were also, it seemed, always conditioning on historical frames, like not just in the KV cache, but keeping some of them like maybe literally in the context. So those are different ways. But you're right. We wouldn't expect dramatic change. It's more like what I wouldn't expect, though, from a model that has been tuned to generate interesting infinite length video is I wouldn't expect the same thing just to kind of loop on itself over and over. I wouldn't expect chaos, but if we're looking at two mice in a tower, I would expect them to either be building the tower or taking down the tower. Especially because if we went back to that, I bet the prompt is two mice build a tower, not, as you saw in the base model, two mice nod their heads next to a tower, or in the case of the other, two mice nod their heads at a tower, and suddenly the top half of the tower disappears. Right? Neither of those are satisfying interactions or videos, even for the dullest prompt we can possibly imagine. But if you have seen, there are some chaotic videos of the frames not really coherent. Yeah, I think the chaos in the RL actually does make me think that the tuning just introduced degenerate behavior. And that's what happens. If the RL loss is not like really, really, really well defined, even a few thousand steps can force our diffusion model to sample things we actually won't like. So I wonder if it's that the model is not good or if it is done deliberately. I don't know. I don't know if the authors look at that and they think this is what we wanted. It's hard to say. It's hard to say if they think that some of the things we saw are good. I can't imagine they are super happy with it. I think they're happy with the numbers that they got on the VBench long, but like when we saw like the cat like teleport into the frame and then the top of the tower disappear, or in the lighthouse, like suddenly there's a boat. I don't know if those are what they're looking for. I think actually if we go back and look at those examples, and a lot of them, they were more consistent than the base model. But like I said, I don't know if the base model uses the frame sync. And so they may have just been kind of demoing, oh, look, we use frame sync. And you don't need RL to use a frame sync. So I don't know what to think. You do need RL to use a frame sync and not have frame sync collapse, probably. And they kind of do avoid that. So I guess that's nice. Anyway, let's be done with this multi-hop paper. By the way, I got a couple more of these in me. So I want to look at this guy. And when I say I have a couple more of these in me, I just mean I got soccer to go to in a minute. Kids soccer. You ever watch young children play soccer? They just kind of run into each other the whole time. It's fun. I try to tell myself like it can be frustrating sometimes. It's like just kick the freaking ball, but like also they're never going to be this young again. It's kind of like with my younger one. I really want to do T-ball next year because it's like you can only experience the chaos of T-ball one time, and I don't want to miss my chance to experience like all the tiny kids like with the bats. There's something hilarious to me about my like the image of my toddler with the bat. You know what I mean? It's like I went to all the work of like trying to raise her, and it's like I deserve to see her swing a giant bat at a ball on a tee, right? I don't know. Maybe I'm weird. I just there's something about T-ball that I feel is magical in a way. But anyway, okay. Foveated diffusion, efficient spatially adaptive image and video generation. So, oh, timer. Efficient spatially adaptive image and video generation. So the growing demands for high resolution makes efficient generation challenging. Their work tries to optimize the efficiency based on the user's gaze location or estimating the user's gaze location like by eye tracking. So it starts with the mask modeling the foveated resolution, which is like based on where you're looking, to allocate tokens non-uniformly, assuming higher token density to foveal regions, which is where you want to look, and lower density to peripheral regions. And whoa, okay, so it'll generate stuff where like the car would be clear because you look at it, but the rest would be blurry because you're not looking. And so that's the gist of it. We're going to generate very sharp things at things that draw your eyes to them, which becomes especially true in video, right? Where you track the main objects of interest, and we won't waste so much compute on the other things. How do they do this though? These are preliminaries, yep. So foveated tokenization. In foveated generation, we iteratively denoise a foveated token sequence of reduced length. Instead, okay, but how do we determine the foveated sequence? How do we model that? How do we process just that foveated sequence? Dang, I didn't get anywhere close to that in a minute. I think it's pretty interesting though, and so I don't think it's my fault. I think the papers that lend themselves well to the minute are like incremental things that do like one thing, whereas this seems pretty neat. Okay, so we do get a token sequence of reduced length. How exactly though? How do we know the is that not in this diagram? So the tokens are split into high and low resolution grids. Yeah, so the blue is a high resolution, and we just generate that part. The green is the low res, which lets us generate the rest. How do we know that? How do we split those? And they look to be split post hoc. Because I would assume that this model is flexible to where any region could be the foveated region. I highly doubt it just assumes that the center is foveated. So they employ a foveated training tool. Okay, so they're going to take pre-trained DITs and adapt them to foveated token sequences by using low rank adaptation, which is fine. That's just like an implementation detail. Maybe if they had more compute, they would have trained the whole thing. Who cares? The image and its downsampled version are independently encoded by the VAE encoder. Oh, okay. So we get some tokens from one resolution and some tokens from a lower resolution, and we merge those. At training, I think I get it, right? At training, we could just decide any resolution is the foveated resolution. We have a pile of high-res tokens, a pile of low-res tokens. We take some high-res tokens, and then we fill in the low-res tokens for whatever the high, or actually a better way to put it is we take some low-res tokens, and then we fill high-res tokens into whatever regions the low-res tokens don't occupy. And I suppose we know where the tokens go to always put the high-res ones in the... Yeah, that would be easy. That would be easy because the low-res tokens define an order. The high-res tokens just slot into places in the low-res sequence, and so we just know where they go because we can put them into those spots. So the token ordering is easier than I thought when I was first looking at this. What am I missing then? I think I understand how we would train such a model if we can make assumptions about the region that we want to be the foveated region. I think the flow matching training could be pretty basic. And the mask is going to define this other stuff. Where do we get the mask? I think that's my only remaining question. Or is it always the center? Which is fine for like the paper starting to explore this idea, but not the most. Okay, see here they're changing the foveated. It's not always on center, at least at inference. Wow, okay, look at the resolution difference on the foveated region, like compared to baselines is crazy. Uh yeah, this is the native high res, and then this is theirs, which has okay, so the idea of this to remember, the point of this is we're not going to generate a better image, right? The point of this is we're going to generate an image where the region we care about is the same quality or better than before, and we're sacrificing the quality of the other regions in order to improve the efficiency. I still want to understand how they're doing the masking. And in another life, I'd want to look closer at the rope, and specifically how they're changing the coordinates to account for the fact that the patches are different sizes. Is that just right here? Okay, that looks pretty straightforward then. I don't think that's too complicated. They basically just they have a high res attention and a low res attention, which for they have a high res attention and low res attention where they're not going to sample and they're not going to necessarily include all of the high res tokens in that attention. Maybe I should look at that closer. But then for the high res attention where you have to have both low res and the high res together, it looks like the rope will just pretend it's on the same coordinates as the high res tokens. And so we'll just skip based on whatever the low res X is. I kind of want to know how this low res versus high res attention works now, especially because we're using a LoRa. So it's not like we have flexibility to totally re-architect the model. Can I find this attention definition? Okay, foveated tokenization. No, I think that's okay. Wait. A mask. Do they define the mask? We are given a foveation mask. Okay, maybe I should just look up mask if I really want to know how this mask works. Oh my goodness, maybe I don't want to just look up mask. I'm still not sure how we're like. I'm not sure how we are. The scene, most importantly, in foveated rendering, the scene content is unknown a priori, and the foveation mask is known via gaze. Yeah, but we like, are we always just guessing on the foveation mask? Because it does say we are given. User specified. Beautiful. In training, I suppose that means we're just going to randomly sample some. I wish I could find that. I think I'm happy assuming it though, and I'm just going to assume it. I would love to see this low res attention idea. I would love to see it expressed visually, other than just showing me the indexing for the rope. Maybe it's just in this section. Oh, okay. For attention with low resolution query tokens, we subsample high resolution key tokens and normalize the rope indices to low resolution grid. Please refer to this other paper for more details. Don't feel like doing that right now. I'm just going to assume naively, they do attention with high res tokens, they do attention with low res tokens, and they combine the results somehow. Some kind of concatenation, or they could do them sequentially. They could do the low res and then the high res. Those are ways they could do it. I guess you can look at this paper if you are morbidly curious about it. I suppose they don't just define the rope for the mixed resolution DIT. Oh, for mixed resolution DIT, yeah. So they're defining the low res. So this is borrowing ideas from the mixed resolution DIT. If that's a mixed resolution DIT, then are we comparing to them? Surely that's not what naive is. That seems like it would be a little silly. I kind of wish we were comparing to whatever that model was then. I don't think that's what I'm seeing here. Still, I think it's an interesting paper and an interesting idea of a way to dynamically allocate the token budget. I don't think it works very well in image because, like, we have enough time to look at most images to where it will look weird and bad and kind of dumb if I ask for Golden Gate Bridge and it gives me this. And it, like, decides, oh yeah, we're going to be like pretty just blurry most places, because I really don't look at the Golden Gate Bridge and look at this region that's been defined here. And even if I defined a region as a user, I'd almost, like, if I only care about that region, why generate the rest of the image? Video, on the other hand, I don't make as many choices about where I look. My eyes are sort of led through the video in terms of the motion. And so that's where I find the idea very compelling. And that's why I was excited to open the paper today. The kids just need more RL training. Yeah. Or they don't. I mean, I'm trying to enjoy it for what it is, because the problem is they learn really quick. And the crazy mistakes they make now, they don't make again, typically. Not the same kind of crazy, different crazy, and less crazy each time until eventually they're just regular, boring old adults. Uh, hey Matt, have you ever been rejected by AI reviews? I get AI reviews quite a bit. Have I ever been able to blame them for rejection? I'm not sure. Because the funny thing is, it is kind of random, and it's not like the AI, as far as I can tell, has a big reject bias. If anything, they might reject a little less than the human reviewers. And so I'll actually often have papers where I find myself getting super frustrated with the review, and I'll start to realize it doesn't quite make sense. I'll throw it at a detector, and it'll be like 100% AI, as opposed to, it could say AI polished, for example. It'll be like 100% AI written. And then it's like, okay, do I know for sure it's AI? No, right? It could just be a person that writes a lot like AI. Not very likely, but it could. But then, for curiosity with the same papers, I'll often throw my other reviews at the AI, and sometimes my strong accept was an AI review, right? Um, and so often when I find myself getting frustrated and I throw them all in, it's a bit of a mix. Uh, and to this date, all of my most problematic reviews have been human reviewers. That's likely to change though, because actually I have a paper under review right now, and there are 2 reviews where I think so. This conference, ICML, watermarked the papers. So if you threw the paper into the AI, like the whole paper, it would read the prompt injection and it would give you weird stuff. They don't have that in it. So I think they didn't just throw the raw PDF, and I'm not sure if they used very good AI, because some of the questions they ask are answered very directly by the main figures. Um, so it makes me think they just piped the text. They're not all bad questions, but they would be answered by even like a rudimentary level of comprehension and simply having seen the teaser, for example. And then other questions would just like throw words at us that didn't make sense. Like it would make up concepts. It would take words from our paper and rearrange them and like make a brand new concept, a concept that might mean something with respect to another field or another paper. So it's not like it's a concept that's invalid in the world, but it's not a concept that is in the paper. And it would ask us about it. It's like, so explain how this, or it'd be like, so you have this problem in this part of the pipeline, explain how these 2 factors affect it. And they're 2 factors that have no presence in that part of the pipeline at all. And it's really hard for a human to get confused that way. Humans could, they totally could. But when enough of the review is that kind of concern, that's when I get suspicious. And then I throw it to the detector, and the detector confirms. Do I know 100%? I don't, but I strongly think it is. And so who knows? If this paper gets rejected, I would definitely blame this AI review. That gives a lot of signal that I think is just kind of random, because a lot of them are questions that don't concern the paper. On the other hand, I have seen AI reviews that are quite high quality. I think it depends a bit on the model, and I think maybe in the cases that they were quite high quality, perhaps the human did some supervision, right? And made sure that everything the model said aligned with what was in the paper. So I'm not trying to malign the AI review. And I do think that if we're talking about AI generation academia, the far bigger problem than AI review, much bigger issue is AI paper. AI paper is going to waste so much more of everybody's time than AI review could ever possibly waste. Because a review, I think, is a lot more constrained, right? Like the review is supposed to be based on existing knowledge, either knowledge that existed before the paper plus, whatever's in the paper. Uh, Whereas the AI paper purports to contain something new, and the standards and the burdens are much different. And like an AI review, in the cases where it's bad and no one realizes the ways in which it's bad, maybe it results in my paper being rejected. But that paper's still in archive. The code is still on GitHub. People can still read it and use it. The community moves forward. Whereas every AI paper, 3 reviewers times 2, 3, 4, 8 hours, plus AC time, plus PC time, plus whoever had the misfortune of reading the thing on archive. So, yeah. Do you think papers are needed to get into a decent PhD program, not e.g. MIT or Harvard nowadays? Arena, if you're talking about in like computer vision, natural language, ML, absolutely yes. You probably need a paper or outstanding letters talking about your research ability to get into anything. I'll just throw out top 25 is something I'll say right now. Not fact checking that rigorously. To get into the University of Maryland, the median candidate accepted has a good paper. But perhaps there are people with great letters that make up for not having, strong paper. So yeah, the bar is pretty high and it's a bummer. It's really hard. I feel bad for people because you have to be lucky or privileged or very, 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 no, it's just lucky or privileged basically sometimes to have known about research on the right timelines to have a paper by the time your applications are due midway through your senior year of undergrad. So I hate that that's become the benchmark because we're measuring something that has nothing to do with your research. We're measuring like serendipity, and just because serendipity touched you once doesn't mean serendipity is going to touch you again. There are plenty of people who could do great research during their senior year, but that is not going to help them with their grad applications that are due in the middle of it, right? So it means like maybe outstanding candidates, a lot of them have to take a gap, and that's just a bummer. Anyway, it's 9:53. Like I said, the soccer schedule is wrecking what I had originally planned to be the stream. So for those of you that weren't here earlier, I am going to relocate the weekly stream to tomorrow. The time I have in my mind is 9 a.m. I'm not going to announce it. I'll just go live at sometime tomorrow, and then I will announce it going forward. I still need to think if it's 8 or 9 or 8 or 9, and maybe I'll wake up before 8 tomorrow, and if I'm kind of not feeling until 9, I'll just kind of wait till 9, because sometimes I feel like that 8 a.m., I'm like super low energy, and it's just kind of a bad time for everybody. Anyway, thanks for coming to the stream. I'm glad we could read a few papers. I know we didn't go super quick, but I kind of felt a little bit calmer and a little happier, I think, with the amount of attention we gave these papers than I did with what I do sometimes. So we'll be live tomorrow. Like I said, 8 a.m. or 9 a.m. Definitely don't set an alarm for 8 because I'm not promising anything until 9, okay? Anyway, take care. Thanks for watching. Bye.